9:30, no? We're getting there.
Where we'll introduce you to the new workflow that this video, where we'll introduce you to the new workflow that the Environment and Sustainability team has been working on to create interactive virtual tours with 3D Gaussian Splatting technology to showcase the sustainability features of ZHA projects worldwide. This process is powered by 3D Gaussian Splatting or 3DGS technology, a cutting-edge method for photorealistic 3D representations. After testing it here in the ZHA gallery, we decided to take the XGRIDS portal cam with us to China for a field survey. These models are built for digitizing real environments. They are perfect for interactive exhibitions with embedded metadata or for remote construction sites inspections to check building evolution. We are currently building a library of ZHA environments. This database will serve as the foundation for our own virtual tours, and eventually will integrate our on-site environmental measurements. Accessibility is key. 3DGS runs smoothly in computers and smartphones. If you miss a China trip, don't worry. You can explore the latest project samples that we made available for you in our SharePoint page. 3DGS excels in capturing complex reflections, glass, and fine vegetation details, where traditional photogrammetry methods normally fail. With a strong GPU, you can explore models and feel less like in a video game and more like walking through a high-definition photorealistic model. To learn more about these technologies, please reach out to me or the Environment and Sustainability team. We'll be more than happy to assist you. Thank you very much and see you soon.
Hello, everyone. Welcome to today's webinar. And good morning, good afternoon, and welcome everyone from the different countries of the world. If you are here in the live link, please say hello from anywhere. For example, hello from Hong Kong or hello from the UK. Thank you for joining us for today's webinar, Capturing for Sustainable Design, how Zaha Hadid Architects is applying 3DGS across architectural projects, and also some of the experience coming from heliguy, our featured partner. I'm Mindy from XGRIDS. These days, much more on the marketing side. I'm also the product manager of the LCT solution. I'll be moderating today's discussion. This webinar is part of our ongoing series exploring how 3D Gaussian splatting and reality capture technologies are moving from experimental workflow into real-world applications across different industries. Over the past few months, we've spoken with professionals from filmmaking, luxury, real estate, and digital content creation. Today, we are turning our attention to architecture and sustainability and several beautiful scanning results. Architecture has already relied on accurate documentation of the built environment, but in many projects, understanding a site requires much more than measurements, drawings, or photographs. Architects need to understand the relationship between spaces, materials, environmental conditions, and existing context before they can make informed design decisions. That's why we are very excited about today's conversation. Today, we have two featured speakers. One is Carlos, and another is Richard. Please say hello to everybody.
Hello, everybody.
Hi, everyone. How are you doing?
Yeah, you can give everybody a very brief introduction about who you are and where are you come from.
Fantastic. Well, I'm Carlos Bausa. Thank you, Mindy and XGRIDS, for having me here. I'm the head of sustainability in ZHA, but also I'm the founder of Architects project. So today I will show you a little bit of the work that we have been doing with XGRIDS, especially to bring, because my role is to bring new technologies to the architectural, let's say, business, to see how can we frame or publish new ways to release information about sustainability and showcase how sustainability looks like in our buildings. So happy to show you now after the introductions.
Hi everyone.
And Richard.
My name's Richard Dunlop. I'm head of Geospatial at heliguy. So we operate as a UK reseller and partner of XGRIDS equipment here in the UK. Our basis of our company in the past has been drones, but now over the past 6-7 years, we've adopted lots of different survey technologies from GNSS, and more recently we've been working with XGRIDS over the past 4 years. So looking forward to showcase some of the applications across AEC and some of the data sets we've helped capture.
Yeah, very experienced professionals in both geospatial as well as the AEC fields. So in the next part, Carlos will have his presentation regarding the specific case and some of the project he's done, and then will be the Richard's time. So before that, I would like to know if you have any questions here, you can leave them in the comment area, and we will try to answer them, all of them, and we will also have a very great panel discussion in the last session of this webinar. So then let's give the mic to Carlos. It's your time.
Perfect. So I'm gonna let's see if you can see what I have here. Well, fantastic thing. I'm hoping that you can see what I'm presenting here on the screen. Well, thank you, Mindy, and everybody who has organized this fantastic webinar. So I'm gonna go through quickly like 2 projects that are, what I'm doing normally. So I'm the head of sustainability in ZHA, and in ZHA normally we work on making sustainability visible through different technologies. So ZHA is a company that is composed by around 500 people, but internally we have an environmental sustainability team, which is the one that I'm managing. And this group of specialists and I, what we do is like helping and acting as an internal consultant for the practice, where we show them the type of work that, the type of influence or impact that the buildings will have in the environment through different technologies and different simulations. So my work is merging a little bit the world of technology with the world of design to create more sustainable buildings and to help our clients understand how the buildings that we're proposing are going to have a positive impact for the environment through many different forecasting solutions. So we apply simulation and we apply context capture. You will see later exactly how these 2 things merge together. But we realized that simulation on its own is a very useful technique, or let's say workflow, to understand how a building is going to work. But what we like to do in ZHA is help people to understand how these buildings are going to behave in a very graphic way. So the simulation that we do is the same simulation, environmental simulation, that any other engineer field will probably do. So we work on influencing, let's say, the whole design process from very early stages with different type of simulation for daylight, solar exposure, energy, carbon assessment, and a very long, etc. And this information normally is represented and in a very graphic manner, so we can make people engage with solutions and understanding how the solutions will have an impact in the actual real environments. So these solutions and these simulations that we are putting together help us to start from the inside out. So we think, what are the conditions we want to deliver to the people that is living inside these buildings, and we create the envelopes, we create the exteriors of these buildings to look the way they look. You probably know ZHA, and I'm sure people who is joining this call is aware of the type of avant-garde design style that we have in this company. But that's something that it's really influenced by their environments where things are inserted, where these buildings are inserted. So no building is the same, because mainly 2 locations normally could have different climates. So there's a massive aesthetic component. But what we started to think about is like, how can we showcase that? And then we started to look at different technologies. My role is to bring technologies to the office so people can understand better or showcase this analysis that we're doing in a different way. So the portal cam scanner that we got, thanks to also heliguy, help us a lot to understand how a space can be captured with a photorealistic, let's say, look and feel. So we were used to photogrammetry and mesh-based solutions to display locations, but 3D Gaussian Splatting gave us a total new dimension to showcase how the look and feel of a place will be. So the amount of detail that we captured when we did this test in the gallery helped us a lot to transmit to our board and our directors how this technology can help us to move to a new way or a new dimension in terms of presenting how our buildings look like. So we work on showcasing our labs, our office spaces. This is what you're looking at, is the lab that we have in the office with robots. There's a model shop, let's say, place where our teams normally explore geometry and manufacture things. So this helped us a lot to understand better how this could be applied. And then we started to merge it, and we started to think, what if we take this scanning technology to China, to where most of our buildings are located, and start scanning them? So my team and I went to China, with all the equipment that we could gather to take both the, let's say, the scanning of the location plus environmental data, and start merging this later through different workflow. But the scanning, we were like surprised how fast it was to set up the scanning, to jump on site. We did like around 8 buildings in 3 days. So it was like a remarkable achievement to put together, because we were doing maybe 1 or 2 buildings, like 2 or 3 buildings a day. So it was like complex, very scheduled, let's say, tight schedule we had. It was impressive. And we're like going with more people from our office. So we were like doing both, like touring around the buildings and scanning them, and at the same time taking measurements. But what we do with that is to showcase that you don't have massive resources to really understand the environment or capture it. You can just go with a scan. One guy can scan it. In my case, I was scanning some of these places in less than 20 minutes. So it was like a really like a game changer. So realize the scanner was helping us to capture the space very, very quickly and create a very accurate 3D model that can be, showcased with different in different formats and in different devices. So the workflow normally started with the capture, and from the XGRIDS scanner, we use Lexel silver color to basically process and get the Gaussian splat. And then we start looking at the solution for cleaning it with SuperSplat and other software and other tools that we have in the office. And at the end, the final step was to integrate these solutions and these 3D models into a sort of interactive experience where we'll put together all the environmental data. So I'm going to show you like a few projects, and so you can see a bit better what I'm talking about. For example, we selected, before going, we create a very detailed plan of which places we needed to measure. And then from there, we start taking measurements and comparing the measurement with the actual simulation that we were doing to see, the percentage of match. So we're very happy to see that our simulation and the reality were matching 90% or even more in most of the cases. And we went through a lot of different testing, from daylight assessment to actual glare perception, wind analysis, and all this together with the scanner. This is like one of the scannings of the Civic Center in Zhuhai in Shenzhen. And we did the interior, also we did the exteriors. And from there, we just bring everything inside of our own, let's say, customized visualization, let's say, system. This interactive tool is something that we designed in our team. And my guys and I start putting together like the information so we can lay out the measurements directly in the 3D model to basically allow, let's say, remote sensing, so remote surveying. So we can share this with our clients, we can share this with our architects, and they can know live how the building will perform by looking at this 3D model, navigating around, because normally not everybody in a design team or in an architectural team has the opportunity to go on site. I think a lot of people think that architects are continuous traveling, but when you're the production teams, 3D modeling people, technical people normally stay in front of a computer and they don't have the ability or the chance to go to this other country. So we thought this is a very good way so we can share internally this with more people around and show them the results of everything that we're measuring so they can somehow survey or understand how their spaces perform. So we did this also in an office building, also in Shenzhen. This one is called Infinitus. It's one impressive building. And this one, we merged the information with 360 photography. The 360 photography gives you a different level of photorealism, obviously, but it's quite useful, so you can get a very quick understanding of how the space looks like. Sometimes the models have to be reduced in terms of quality, so they can be played in a computer, they can be shared online. So I think the Gaussian splatting is covering, let's say, 90% of our visualization demand, and the other 10% we just cover it with the 360 photography because that gives us the final photoreal resolution. And on top of that, we keep adding the information about lux levels, sound, and air motion, etc., to showcase the comfort levels that the buildings will be able to deliver to the users. Also, we did that in the Shenzhen Museum, Science Museum. That's another building that was recently inaugurated. We took a lot of measurements here to understand better how, even in a cloudy day, this building can still deliver good light levels and good comfort conditions. So all the buildings normally get designed, taking into consideration all the information about the environmental assessments, and we use them to optimize future generations of iterations of these same buildings. During the design process, normally help us to optimize the building. But Gaussian splatting here, for example, I was like surprised to see that even if there were like more than 500 people running in this space when I was scanning it, I was mentioned that to Mindy and Richard earlier. It was challenging to move around. It was fun because when you're scanning the space, it's like a choreography. You need to go slow motion, and then people's moving around very fast. So you look like a guy who was like stopping time, walking around these places. But again, this technology helped us a lot in the office. But at the same time, I'm very passionate about photography and context capture, and I started like an external project that this is sort of like a non-profit, let's say, organization to really help organizations that are managing heritage sites to reconstruct locations and reconstruct things with this technology. So I'm going to show you in this other half a little bit of this project, how it works and how I started it. And basically I started it because I have passion for travel photography. So for some time I was like gathering a lot of equipment, testing a lot of technologies. That's something that's also helped me a lot in my day-to-day job. I normally go around, check what's available, what new drones are producing what, and see how these drones, for example, can be combined with other different software to produce different things. And at the beginning, I was focusing on travel photography, but over the time, I realized, wow, context capture is like taking a full photograph of a whole space, and you can even take a snapshot of that photograph on that 3D model and capture the essence of the space. And later you can see if a place has changed. So I started to think, well, this can have environmental purposes. If we monitor or scan an existing location, we can see how in a few years' time this location can change or can be affected by climate change and stuff like that. So I brought this to most of my trips. This is scanner, the Lixel K1. It's incredibly portable. That's why I like it, and it was easy to travel with it in a backpack. Didn't need to have a massive backpack or something crazy to travel with it. So I took it, for example, in this example, to Mexico to 3D scan a piece of jungle and a location that has impressive waterfalls. But this area is incredibly threatened by climate change. So I thought it could be useful to take a scan. I did it last year, but with the vision of coming in a few years to see if climate change or the industrial agriculture pressure in this area is affecting it. So I did these scans. What you're looking at right now, it's a scan. If you take photos of the QR codes that you see, it will take you to the full video and the full documentary that I was posting online in my website. But I found this technology incredible to really capture every fine detail. So I thought like maybe for biologists or maybe for people in other industries that are not even connected to architecture, this technology could help them to really understand how places evolve. So I was doing a lot of kind of testing with this technology in the specific side. I did it to showcase, the level of accuracy that you can get, because also I think like film industry used this a lot from friends that I have in this area. But I realized when I tested it myself, I was like completely impressed by the level of resolution and detail that you can get with this. And later on time, I feel like my timeline this is how I started looking at this scanner even before in Zaha. Zaha didn't know about this. I didn't know about this technology until a couple of year and a half ago. Then I did these trips and I did these scans and brought this to my directors and told them, guys, this is amazing. Why don't you put this into our buildings and start scanning our locations, because this could be amazing. But again, uh, I thought also helpful for heritage. I think a lot of people in heritage business are looking at creating digital twins of their places. But I felt like why this is important, because mainly the physical world is fragile. So I feel like heritage sites or natural sites are very subject to change based on the different pressure that they receive from their environment, either climate change or human activity. But I felt like, wow, this could be good, because coming from Spain, that's, you have seen wildfires uh, everywhere in Spain. A lot of towns have been affected and even burned and reduced to ashes right now. That means that heritage sites are being affected everywhere in my country. So I started looking at my country first for this sort of applications, and I felt like, yeah, I've been living in locations near to earthquakes. My hometown was like a few kilometers away from the epicenter of a massive 5.1 earthquake that's destroyed a whole city. So I've seen that with my own eyes in 2013. But also we see floods affecting cities. We see volcanoes in La Palma. So we see dams in many different locations that cover towns. So I thought like, wow, what a pity. This place is probably could have been at least survived in a digital format if someone could have gone there with the right technology to 3D scan that could be used for reconstruction, or at least could be used for keeping the historic memory of these places. So started this project of merging photography, documental photography, and 3D scanning to try to preserve at least some of these sites that I know. And this, for example, a site in my hometown directly, there is the remains of an Arabic castle, a Muslim castle from the 12th century. And this has been, really damaged by different earthquakes over the centuries. But I wanted to merge 360 photography, 3D scanning, and 3D modeling to try to get an interactive experience that speaks about the location on its own without the need of having a guide to go there. So that's something that you can have even in a QR code. You can actually visit the video, see the full project from the QR code here. But at the same time, these are things that if you get an interactive experience in 3D, that can be attached to a QR code in an information panel, and people on their phone could be able to know more of these spaces. And because this 3D scanning has survey accuracy, you can really get to the point of him using this for measuring or taking accurate dimensioning of these locations. And the workflow for capturing or creating something like that is quite simple in a way. It's just you just need scanners, the right equipment for photography, 360 photography, drones, and the right software to create this sort of 3D spaces. And this can be useful for either academic and let's say research organizations, or for companies, organizations that are in charge of preservation, and because that can help you later to rebuild these places with information there, or create digital twins with the information that you gather from these scans. I feel also from the point of view of tourism, that's kind of useful as well, because you can also showcase the spaces to visitors in a very interactive way. So I love it. But of course, after living 10 years in the UK, I thought like, why not to have a look at this country that also has suffered a lot from especially coastal erosion. We have literally, uh, a lot of heritage places at the edge of cliffs. And I did my own survey on which sites could have more potential to be damaged, and started to talk with English Heritage to see if we can, work together in a project to digitally preserve these locations with digital twins around the UK, with the idea of creating not only, let's say, virtual walkthroughs of digital twins, but documentaries that raise awareness of how climate change is affecting heritage in this country. So I even did a test in this country in a place called Reculver. Reculver Towers are in Kent. It's an impressive site. If you had the chance to go there, it's impressive because they have Roman remains from a fort, and they have these impressive remains of an ancient parish church. And from there, I started to build this idea of bringing this to the UK and creating this project to showcase, the ability that this technology has to be imported into a digital twin or into an interactive virtual tour that can help people to understand better what's going on there. So these virtual tours, normally I design them with a lot of information that can be gathered from different sources, which I normally add in citations there so people can check where the information is coming from. But then This is like non-profit things that I do just to raise awareness of climate change and how climate change can affect your immediate surroundings, especially in this case, heritage sites. And just to finish this a little bit, the idea that I put together with this is to work with AI. And AI also helped me to reconstruct these locations in a more detailed way, because you can really understand how these places are going to be affected by all these problems if you create like a proper reconstruction in the using AI, like modern tools of AI that have been right now readily available, to really understand a little bit better how these places can help or were once back in the time. So I did a time lapse. That, to be honest, I'm not sure if this time lapse is playing correctly right now. It looks a little bit slow right now on my end. But anyway, let's see if I can fast forward to the final results and see if I can escape from here. Oh, sorry, I'm having a small technical issue here that I'm going to try to fix very quickly because it's connected to my battery. That's sorted. So I'm hoping that this will be back to life. I'm sorry, apologies, these are the problems of live events, but I feel now it's sorted. So let's see if I can come back. So I was using AI to basically reconstruct these locations to its original state, because obviously you go to heritage sites, and I feel heritage sites are great, but you don't know exactly how they're going to look like or how they look like initially if there is not like a proper visualization. So I found very useful AI to create reconstructions out of the remains that you have, the few photographs that you can produce during a survey, but also the way that you can integrate existing documents like graphics, paintings, sketches to rebuild or understand how these sites look like. So I did this test with this location to really understand it, and started to produce a documentary, which hopefully I will have it released soon in my website. But I'm just basically kind of documenting a little bit of this process for other people maybe interested on these topics to understand how to do that. But I take it to the next level and I start thinking, what if you don't even have the chance to find the location and you want to reconstruct a location from archives or from digital archives? So I'm just gonna bring very quickly in the last 5 minutes or less a project that I started working on not a long time ago. That is the reconstruction of the heritage of my family. My family came from an impressive town in the 50s that was completely obliterated due to the expansion of an industrial plant for oil refinery. So from digging in albums of photos, I started to initially think about how to digitize them. But this town, for you to understand the importance of this town in the south of Spain, it was called Refinería, or Poblado de Repesa in Valle de Escombreras in Cartagena. And back in the days, Spain in the 50s looked like that, but they built a town that looked like they traveled to the future, because this town looked like something taken from the 80s. But these were the 50s. So I started to reconstruct photographs with AI to understand better the place, but I realized that the architecture was like actual modern architecture. And that's because of influence from American architects. But unfortunately, the whole town and everybody was displaced because of the expansion of this refinery. So with AI, I started to rebuild plans that they don't exist, and suddenly the photographs out of plans, like 2D hand-drawn plans, to better understand that, and also started to rebuild some of the buildings and the city itself to restore it as a digital twin, thanks to the use of AI and 3D modeling tools. AI today can help you to create that, and this can be translated into 3D technology later. That's what I love. So you can have a mesh, and from that mesh, you can create a Gaussian splat that can be visualized with any other Gaussian splatting tools that you work around. The AI reconstruction started to help me to rebuild images that doesn't exist anymore out of black and white photos, and photos that my family very kindly provided to me. And all the people that we know who live there, probably what we're trying to do is a collaborative project where more people can contribute to rebuild this place in a digital format, so we can restore the historical memory of this location and help more people to, bring back a little bit this location that mean a lot for more than 500 families and more than 3,000 people that were displaced from this location due to the expansion of an oil refinery. So final reconstruction will be hopefully soon available. I will try to make it available so more people can check it in a web app that will be collaborative, so more people can contribute to the project. But this will be my journey in the work of using Gaussian Splatting, interactive visualization, and AI to reconstruct places and also to transmit how buildings can be more sustainable, also to transmit more sustainable ways of living, I think. And I'm hoping that with this process, I can create more awareness to go into a more sustainable, say, world in the future. Thank you so much for having me here, and I will just leave it here for the moment.
Yeah, a very great presentation. And I think that's what all the presentation just full of stories. And those stories just take us to the place that I was never been. And actually the immersive and interactive experience bring me there, just like I was there. Yeah, so that's the charm of the 3DGS. And so before we enter into answering other audience's question, I have one I'm very interested in. So during the whole process, where in the architectural or the sustainability workflow have you found the greatest value for 3DGS for all of the visualization technologies you've adopted in this process?
Well, I think like 3DGS help us a lot to create a sort of like a canvas for the information. So I found it that for us, for architecture, at least in our industry or in our practice, we find it as a, let's say, like a medium to transmit information to our clients and to our own teams. And that canvas helps us to place information on top of it in a way that we can basically avoid sharing PDFs, or we can avoid sharing other documents, which are like, in a way, more standard, but not very engaging. So I feel like what the biggest problem that we have is like very often we talk to people who are not experts on these topics. So we always need to find ways to transmit it. So our logic is like, if a general audience or a public that's not specialized can enjoy this information, we'll have way more chances to really transmit and make these projects available for more people, or make more people interested, more clients interested into this sort of things, because very often we say that green building features can become an added cost, and you need to showcase why they are important. And 3DGS technology and Gaussian splatting and the type of technology that XGRIDS is providing us to scan our locations has been pivotal to really transmit these ideas in a much more engaging way.
Yeah, so I think that's, yeah, I just asked one of the audience that in the comment area said that it could be very useful for the education, client presentation, and also starting with streaming effects with where all of the things can be shared clearly in a visualized way. And we will choose several questions in the comment area. This one is from your fans, Freya. Is the app colors demonstrated the new platform Zaha developed for client presentation? How did the client find about this? Is it easier for them to understand?
I think we use it as a sort of presentation background. We normally give this to clients or to our teams for them to explore it, but we normally organize workshops with them for them to understand it. So I think it requires a bit of, let's say, introduction to the topic, so they can understand what to expect from it, what they can read in that information, why this information is useful. So normally when we look at certification systems, certifications have very clear targets that you need to deliver in terms of, daylight or thermal comfort, stuff like that. And these are the proof, or at least we do the survey internally. Obviously, you need always like a third-party verified survey to sell the product. As you can say, my product works very well, but it's your product. At the end, you have the interest in the topic. But we do this to basically say, okay, this was validated by an engineer. The engineer give us the data. Now we put the data into the 3DGS environment, and now you can see it in a way that you can understand it way faster. And at the end, that helps us also to show it to the user of the building. So once we have done openings, sometimes we have screens, interactive screens in the openings and the exhibitions. And when we had that, there are instructions on what you can do there, but people really like it because they stay there for some time clicking things. And this way you can make people a little bit more aware of the solutions, and also you can make them aware of the things that are invisible. You don't know lax levels by looking at the floor. You can sense if place is bright or not, but at least with this we can give the values that tells people, certifications are asking for this. these are the values that we gather for specific, let's say, types of measurements that we have to do in every building, and we can transmit and we can educate people. So it's sort of like educational dimension also attached to it that we love. And yeah, it helps us better than showing someone a piece of paper and say, listen, these are the values, just check the values, which are great. We need them, of course, but the other one help us to transmit in a more engaging way, an interactive way as well. So
Yeah. So for me, I think it's like a 3D context, so you can understand the whole context in a more comprehensive way, and with all different kinds of methods combined together. Yeah. So I think that's also the benefit of that 3D things. And I think Freya got another one to extended the question, can we demonstrate aerodynamics in 3D in the future? Actually, I'm not so familiar with these concepts. Aerodynamics, is that certain terms in sustainability area?
I think, well, there are different ways to transmit that. So we have done interactive visualizations with meshes, like 3D meshes, where you can actually show the mesh result. Meshes normally are like a surface where you get some colors and it creates like a heat map. So we showcase these heat maps are easy to be shown in 3D because you can create a section of a building and you can plug it there. So actually, something that we wanted to explore is to bring those kind of color-coded meshes that tell us more information about lighting distribution, solar exposure, or computational fluid dynamics like CFD to understand pedestrian wind comfort or the stack effect inside of a building to see if there's natural ventilation happening. These are things that my team keeps exploring. We did these presentations in the same interactive format, but not with 3D. We use like more conventional 3D modeling. But yeah, in the future, I'm sure we'll get there where we can merge the actual meshes with the 3D Gaussian splat for that. Not so sure about using the 3D exactly for making the actual analysis, because it's not like, I think most of the engines that we normally work with are mesh-based, so you need to provide a geometry in a specific format, but they don't still admit 3D as an option. That's more like in the engineering, let's say, software realm. I'm hoping that in the future, if a software company can do something that admits 3D probably will be great, because then we can 3D scan a place and run the simulation in that 3D model. But I think at the moment, I feel it's not there yet.
Yeah, so that's also an interesting direction for the 3GS or related technology to move forwards and to fully understand the industrial needs and what kind of data should be combined together. And we got another one from Remy. Hello there. For the measurements, are you backing it up with the point cloud in the back end? How do you ensure the accuracy of the measures? Thank you.
Exactly. I think that what I like of the Lixel K1 scanner is that you can get the point cloud at the end. I didn't show it exactly because I was having limited time, so I focused more on showcasing the 3DGS technology, the 3DS visualization. But yeah, the point clouds are matching very well from what we experience internally in the office. We did a lot of different tests. I think for the nature of the work that we do, we normally don't look at or work directly with the point cloud, but I'm sure someone doing survey needs this point cloud to create a more realistic or accurate 3D model. I'm sure this can be used. And I think there have been many webinars before this one from XGRIDS that showcase people working with the point clouds as well. Yeah.
Yeah, so I think that's also quite a different point that XGRIDS provides the solution for. So we combine the LiDAR data together with the visual data. And the camera sensors can get very good visual fidelity, as well as the while the LiDAR get more geometry as well as the measurement information. So for sure, these measurement accuracy is backed by the point cloud measurement accuracy. And so by using S-grade series of scanners such as the Lexo K2, K1, L2 Pro, we can output high accuracy point clouds at the same time. So, but actually, I agree with Color's insights, is that 3DGS really lower the barrier for the people who have very little backgrounds and information for those professional data sets. For example, the point cloud is not so much intuitive for some of the clients to understand the whole space. So 3DGS really did a good job to make everybody understand the whole context. And as a backup, the point clouds also keep that accuracy can be get within one project. So, and let's get into another one from Daniel. I think Daniel come from UK as well. Really interesting, Carlos. For the location you demonstrated in UK, is the interactive data hosted somewhere? It looks an interesting platform. I think it's it's about your project, the new project.
I think like the archive part. Yes, I have some of the data sets available in the not the data set, but the experience, the interactive experience for a couple of projects there. And all this, I'm still in conversation with XGRIDS to see how can we develop that. But I feel like, yeah, hopefully soon we'll get more, you guys will get more access to this type of projects, so you can see a little bit more of the journey that I'm following here in the UK. Hopefully soon.
Yeah. Yeah. So for that hosting services, and XGRIDS provide free hosting services. If you publish the data sets directly through LCT Studio after you finish the processing 3DGS. And you can also output the data sets into different formats, such as the PLY, LCC, or different the mesh OBJ file to host that into your own server. And then we also provide that totally offline processing solution for those cases that the data privacy is really an issue. So I think that data hosting is only an option for different projects. If the client requires that the data sets be public, and we can use like different servers to host it. And especially we have a European server to host the data set. So no geospatial or the spatial data sets will be released to other area. And hope I can find with this. Yeah, another question comes from China, from Molly. What would plan to do around these historic projects, AI films or any other purpose?
I think, well, that, I mean, my purpose was to showcase and the awareness of climate change, how these places have been modified by climate change, because my background is working on environmental, let's say, topics. But I thought this could be interesting to, if it's related to heritage sites, it's also good to know a little bit better how the sites were, or the importance of it. That's where AI started to come handy, because sometimes you get places that only have ruins available. And if you try to look for in the internet for information how these places look like initially, either you find, like 17th century sketches or watercolors from some artists from the Renaissance. So it's not easy always to find this sort of information. So my conversations internally here with Investigators was about helping to rebuild with AI and obviously the information available to try to be very accurate to the actual sources, how these places could look like. Of course, 3D modeling can play a big role, like manual 3D modeling. It's important, but it's incredibly time consuming. You need massive amount of resources to have someone 3D modeling a location to its original state. If you try to follow a typical, let's say, 3D or BIM related software path, but AI is helping. Right now, I feel there are like very interesting AI tools that produce high accurate results connected to maintaining perspectives, maintaining details without, the typical hallucination of other engines. I think that there's a plethora of engines around. Probably whoever's working with AI knows that there are many different engines that work and produce different results. But in architecture, we normally try to look for the ones that create very accurate results based on what you want to do. And I feel maybe 1 year ago or 2 years ago, the industry was not there, but now we see that you are able to get more control the same way that you will get in a 3D normal environment to get what you're looking for, not what the software wants, which is a very different approach to add a prompt. It's easy, everybody can do a prompt, give me a charge, but that's not what you really want. You want to really have plans, you want to have things that need to be followed, and the prompt engineering normally has to be developed considering these parameters that you have to define, which makes the workflow a bit more complex. But yeah, I'm hoping that in the future you will see more results of this, and also in our platforms and social media. I think we lost connection with Mindy. Mindy, are you around? If not, we'll keep going back to the AI part. But I feel like if someone's listening to AI related to the AI workflows, I feel there are like a lot of tools and a lot of people ask me about it, how this can be done with more precision. So I feel like most of it, it's something that you can attach control based on the amount of information that you have available. And that's what makes the tool a bit more useful. But I feel like, again, it's a workflow that requires time, that requires like patience as well, because you don't get the results that you need at the very beginning. So something that you need to really add layers of improvement and modification so you can get to the images that you need or to the images that are more precise in a way. Well, I think Mindy, you're back.
Yeah,
All right.
I think that I
Yeah.
got some bad connection, and yeah, everything goes all right.
Fantastic.
Yeah.
So I'll leave your control back.
Yeah, and actually, before I got stuck by the connection, I still find some interesting questions, but it just I just left my uh, dashboard. But I find one from Mohammed. So I just read that question for you. So how to calibrate a LiDAR measuring instruments so that point cloud measurements can have metrological chanceability, especially down to the gauge block. I'm not sure whether you have some
I
experience
think,
regarding
Mindy,
this.
I'm gonna leave that question to you. It looks like it's more from your alley than mine.
Yeah, that question can be actually solved with some georeferenced data, the RTK module. And in XGRIDS solutions, we provide RTK module together with the K series and L series scanners. So with those RTK, you can get georeference data from your local servers. And we also use a control point base to get relatively accurate data sets. So hope that my answer can help you. And then later on, let's move on to the next presentation. Thank you for colors joining us for today's presentation. And later on, we will try to, after all the presentation finished, we will introduce colors again back to the stage and to answer all of the questions. And then the next station, the session will be Richard.
Hey, are you okay? How's everyone doing? So I'll just share my screen now. Hi everyone. My name is Richard Dunlop. I'm the head of Geospatial at heliguy. So thanks for your time there, Carlos. That was a fantastic presentation. So in this talk, it might be a little bit shorter, but we're just going to showcase some other examples of how 3D Gaussian splatting is used across AEC and some of the scans we've done as well. So I'll just get into the presentation now. So if you're unfamiliar with heliguy, we've been operating in the UK for 17 years, and that extends across drones, training, operations, survey, and repair. And then there's a picture of myself to the right. So yeah, I'm the head of the geospatial team here. I've been here for 5 or 6 years now, and my background is surveying and mapping. And then in the team, we also have other areas of expertise around, say, GIS and photography and different workflows. So if you're unfamiliar with heliguy, we started around 2008. And then we've just grown from there. So we started off actually as a toy helicopter company, and then we partnered with DJI soon after. And then from there, we've just grown, and the business has grown, and now it extends to a range of different sectors. So we have like regulatory training, technical support, rental, BVLOS applications, a variety of different things. And the survey side is one part of that. So we like to be a one-stop shop for our customers and our clients. So someone might come to us for equipment, but then we'd like to help them out so they're not stuck there with just the kit. We then offer the training to get them like a drone license, and then if they want to do like training of XGRIDS kit, we can help with the training on that side. we have the support in-house. And our role as a survey side as well is we like to get out and use the equipment. So, you know, when we do the 3D Gaussian splatting and someone wants to try using it, we're there to help out. So we get out and practice quite a bit. So you'll see some of the data sets that I'll share in a bit. So with XGRIDS, we've been partnered for around 4 years. And we've just grown with them, and similar to how we've grown with the drones and DJI, and we've just grown with the data and what XGRIDS are producing as well, and working with a variety of different industries. So specifically with the drone and survey side, so Carlos and what he's been doing is an example of how we've sort of helped onboard a client with the application, and then Carlos is just taking it with what he's doing in the realm of sustainability and what he's doing with Zaha Hadid, and that's primarily how we operate. So someone might come to us for like an application, and then we can show them how a drone might work with XGRIDS equipment. And then also with survey, that can help with like photogrammetry, handheld scanning, RTK and PPK with MLID GNSS solutions. And then also with that, the data and the software needed to get Gaussian splatting, point clouds, 3D meshes, all data sets that can be acquired with the XGRIDS kit. And then from there, the clients usually can then take it to whatever application they need. So it could be reality capture for AEC, could be change detection, BIM integration, that kind of thing. So we have a good team of people here within the geospatial team, and to help out with like drone surveying or terrestrial scanning workflows, and we're here to help out. So client requirements are evolving. So this is now getting into the realm of 3D Gaussian splatting and how it fits in. So with what we post on like our socials and what we post on social media, like it needs to the message needs to be conveyed properly. So conventionally, there's always been like high density point clouds, orthomosaics, CAD drawings, BIM models, those sort of files, and 3DGS is not replacing those files, and we understand that from an AEC point of view. But what 3DGS does, and you can see by the sort of the jigsaw at the bottom, is it's another piece in the puzzle, and it's another deliverable, and when used properly, it can be used to elevate existing conventional workflows and not replace them. And that's what we try and do and help out with people. So the position we are now is people are starting to understand that, and you know, you have your conventional survey datasets which will always have a place, but with the 3DGS data, you now have another deliverable as a virtual like 3D tour, and a different way of presenting visual data rather than just say a 3D mesh or a photogrammetry model. And then this data set with different viewers is accessible to architects, engineers, clients, different stakeholders across an organization. And then as we go into the future, we're just going to see this element grow, and you can sort of argue in some ways that the future is already here. So with 3DGS, this is now integrating with Revit via the XGRIDS Revit plugin. It enables remote site access without a site visit and 3D virtual tours. And as more viewers and more platforms start supporting the file types that 3D Gaussian splats will produce, it's just going to be more accessible, and it's going to grow. And as I say, what Carlos was doing as a prime example of how it can be furthered with AI in different applications. So I'll go into a bit more about the scanners and how we've been using them, and how different companies and clients in the UK have been using these now. So the first one is just an example. You might have seen it on our channels, and with this particular data set, it's of a Victorian Grade 2 listed building, and our area of expertise that we like to sort of support clients with training, and we can showcase to people is this. So this was using a DJI Matrice 4E drone around the building, doing a series of different flights and takeoffs, and then using the XGRIDS Lixel Cybercolor software, we were able to fuse it with the scan data. So this was purely used we got on well with the clients of this site, and this was purely used to sort of showcase the kit and the power of the technology for 3D virtual tours. And it's a good example of how, you know, that model from the drone can be used to produce an all-in-one digital twin and data set. And then we've also been working quite extensively with the XGRIDS applications. And here's another example. So this one isn't using our drone experience, but this time we're using the HD enhancement features of the XGRIDS. So we were really wanting to push it to its full potential and use it on like an intricate site. So this was a studio with the BBC, and you can see how well the scan has done in an area where there's repeat features. By using the phone, just my iPhone 14, we took overlapping photos, merged that in with the scan, and you can see how well the XGRIDS kit can be used to sort of capture a complex data set or a complex area like this. And then this is like, as I say, the HD enhancement. And for a 3D virtual tour now, this provides a really good idea of the site. And, you know, people can then use this if they want to use that studio for like visual effects or whatever they want to use it for, just audio recordings. So with this scan as well, we sort of planned the route beforehand, myself and Alex in the survey team, and then we approached it to get the best data set we possibly could. And within this LCC software, we then disabled like portability mode, which enables the spherical harmonics, which gives you improved reflectivity and colors on the surfaces within the Gaussian splat. And then you can see as well within the well-lit environments how clear it is when you do actually use the HD enhancement scan. So you'll see myself come on the video shortly. So we did it on this piano, and then it's just a case of taking say 30, 40 overlapping photos of this area, and then you just import those in to the LCC software as JPEGs to get the best possible quality scan you can. So the message here is with the past data set, and this one is just, this is what we try and do with clients. We try to understand the kit as best we can, and then we can not only support clients and help sell the kit, but then we can help them out with getting them the best possible 3D Gaussian splat data sets possible, so then they can take it into the softwares that they want to use it in, or use it as a viewer. And this feeds in quite nicely to how we do things. So we call it Survey Assist. So prior to XGRIDS, it might have been called a drone assistive program, where we sort of have a client come to us to get the hardware, do the training for the regulatory side, and then they can do a drone assistive program with a survey focus to understand, say, LiDAR or photogrammetry. But now with XGRIDS and the rise of 3D Gaussian splatting that we've been helping support, it's very much a survey assist. So someone could come to us for drone training and buying XGRIDS and a drone equipment, but then, you know, we are using scanning workflows that we've practiced, refined, rehearsed, and to then relay that information to them, so then they can use that within their organization. So again, this is just sort of showing how it's used. So we've got the Matrice for Enterprise, and it could be either a portal cam or any one of the XGRIDS Lixel series. So that could be the Lixel K2, the L2 Pro, one of those systems. And then with the survey assistive program, it sort of is added a new variable for us. So it attaches on to what would be conventionally GIS drone photogrammetry data. We now have 3D Gaussian splatting, and our assist program supports that. So if someone's interested in learning more about it, we can help out with that. So now I'm just going to give an example of how that sort of survey assist has been applied and used across the industry with some brief examples across from our clients. So this is just one example here. So this is a company called Greybox Geospatial, and they're a prime example of how 3D Gaussian splatting's elevated their current workflows and added a new piece to their jigsaw and their deliverables. So they primarily did 3D modeling in BIM to an ISO 19650 certified standard. So that's sending like Revit models, digital twins, and then also on top of that, adding the inspection services with the drones and the aerial survey solutions. But with XGRIDS, what they can now do is add that 360 tour element with the Gaussian splats, either as an immersive link or a video. And now, especially with these sort of sites, you can see like the complex pipework in these environments. And this is quite a common scenario we're seeing within AEC and, say, critical infrastructure inspection, is these sites are quite outdated with their drawings. So not only can like a 2D technical drawing be produced, but now the clients can send across a 3D virtual tour. And this is like so useful to what they want to do. It helps people visualize a site before they've gone there. And yes, drawings might still be needed, but this is just another element that can be sent to help visualize the site, as opposed to just like fixed panoramic nodes. And then the outputs from this can be exported directly from the Lixel Cybercolor software as a web link, a secure web link encrypted with a password. So for security as well, it's very useful for AEC clients that want to keep it contained within their organization. And then you can see at the bottom just a quote from Jack there, who's the director of Grey Box Geospatial, and how he's been using this data to help visualize and share data more meaningfully, and not just as a drawing or a conventional workflow. And then the possibilities are quite endless, to be honest. And again, following with what Carlos has done with his focus on Zaha Hadid and sustainability, how the splats are used is endless, and it's quite exciting to see where it will go. But just some other examples from clients and how we've been supporting is we've got another one who will help manage lighthouses. So then what they'll need is a 3D virtual tour, and then that can then be imported into the software platform Nera. And then that gives them an easy means of navigating the lighthouse. Say if someone needs to go there for an inspection, they can do that before they get to site. They have a good idea of what they're walking into, so then they can plan. From the Nera model, they could label the assets that need the work the most or need repair urgently. So you're almost saving time before you get to the site with the 3D Gaussian splat, just as a means of like inspection and sort of planning engineering work from there. And let's not forget with the XGRIDS series of equipment as well, you're not just limited to the Gaussian splat. If you purchase, say, a K2, you also have the point cloud. So then that point cloud could be exported as an RCP file directly from the Lixel Studio software. And then the engineering teams could use this for drawings within AutoCAD software. So, you're almost killing two birds with one stone. You're having the 3D Gaussian splat for the wider organization, but then with those people within the organization who are familiar with survey deliverables, LES, RCP files, point cloud files, they have the means to produce the drawings within whatever Autodesk software or application they're using. And then extending from AEC, it's probably broadcast online quite extensively, but it's also used quite a lot in film and media. So we're working with a company called Digital Catapult, and they're using sustainable digital twins for broadcast and virtual production studios. And then, before you get to a production studio, you can have a good idea of where the camera rigs are, and you can plan your shots accordingly. Again, saving time in the office before you get there. And then with the different plugins from XGRIDS, like the LCC2, Unreal Engine, there's so many different variables and ways it could be used in film and media for like location scouting, post-production. The possibilities are endless. Then as we continue, again, the 3D GS data can be used in event planning or showcase. So if you need to use it for an event, you could plug it into Unreal and then show someone before the events happened how it would look on the day. Or more importantly, relating to AEC, and this same concept could be used. So a design could be, produced in like a SketchUp or an Unreal Engine, and you've captured the environment already with the 3D Gaussian splat, and then you can merge the two together to give different stakeholders and clients an idea of how something will look in the environment before it's actually even there. And then extending to AEC again, we're seeing a lot of developments with critical infrastructure. So here's some of our clients' work at the bottom again, like Network Rail and National Grid, and how they've, it can be used in a substation for labeling different assets in the substation. It can be used, then imported into VR. On Network Rail, or for instance, you could tag specific areas of the lines that need the most work, or the gantries above the railway, and attach labels to those in 3D Gaussian splat. So the use of this type of data in in critical environments is again going to only be growing. And it's quite exciting to see where 3D Gaussian splatting will be taken, not just across AEC, but across all applications. So here's just some like general bullet points, again showing how it can be used, and some examples from what we've sort of shown already, but just some examples again of how people are using it. So it can be used in early stage planning discussions across the organization. It could be used for preliminary scaffolding and access studies for the start of a project. It could be used as supporting imagery for concept design narratives, or supplement the existing scan with new designs. Site familiarization and visual context. So again, like adding asset labels for the areas that need the critical work the most, and embedding imagery or videos into that Gaussian splat as well. Or, even just progress monitoring. So conventionally, companies might use a 2D orthomosaic, a top-down view from a drone for progress monitoring. Now you could have a 3D Gaussian splat, which has more photorealism than a 3D mesh to again show how a project has changed and developed over time. And then as time goes on, there's only going to be more viewers that support it. So the XGRIDS LCC2 file is now open source, so more viewers can now import that open source file type that is more compressed than your conventional PLY file. So platforms like SuperSplat, Nearer, Volume AI using this type of data for easy view on desktop, tablet, or mobile. It can be self-hosted, so on-prem viewer for data-sensitive clients, or the data can be embedded in reports. So it can be linked into a PDF report for like inspection alongside the visual imagery. And then design tools like Unreal Engine, Unity, Rhino can then import custom models into the 3D Gaussian splat. So 3D Gaussian splatting in the future within AEC. So we're already seeing a rapid rise, and I think the way it's going to go is there's just going to be more platforms and more viewers that sort of support what XGRIDS are developing and doing. So a couple of prime examples are Drone Deploy, supporting the PLY from an XGRIDS portal cam. So then that can be then used as another means of viewing the site visually. And then you also have, custom viewers like Luminous XR, who we work with, using it as a secure enterprise-ready platform for AC applications and developing their own viewer for their own clients. The XGRIDS LCC Revit plugin is already there to accelerate BIM workflows with AI-assisted modeling. And then there is the LCC2 file type, which is now open source. So again, I think the future is going to be defined by more viewers out there supporting this type of data and helping grow the use of 3DGS. And heliguy position in that is training and support. So, we're not just here to help provide a drone and a scanner. We like to think we're here to, and what we do already is we understand the kit, we understand the deliverables, and we can train people how to use that when they purchase it. And that's how we are positioned with this growing rise of 3D Gaussian splatting in AEC. So if anyone has any questions, there's my email and the survey email here at heliguy. Thanks for listening.
Yeah, thank you for this presentation as well, and very comprehensive to cover all different kinds of industries. And I agree with that. Adopting 3DGS is not to replace the traditional deliverables. So before to answer other questions, I also got one, me myself much more interested. The question should be that are clients increasingly asking for visualization rather than just the surveying deliverables?
Mm-hmm. Yeah, no, absolutely. I think with say the models we've produced online and what we've showcased, people are wanting a taste and wanting to, more importantly, just understand what that data is and how it can fit into their current workflow. So it's not just a case of sharing a video, it's about understanding that it's a navigatable 3D model, and then they can then use that in their application. So we touched on it before, but like it sort of feeds into their existing workflow as well. So, if someone's using a viewer like Nearer already, data can be uploaded to that as a PLY. So I think especially as with existing platforms that customers may have, if they start supporting the data even more, we're just gonna get more questions asked about it, and yeah, people trying to understand it.
Yeah, so I think those visualization is only a part of the project. So it's for people and clients much more easier to understand the whole situation. And also for some of the AEC cases, that the visualization part lets all the stakeholders understand the whole context, and all the team crew member can work in the same situation. I suppose so. And several questions from the comment area. This one from Claire. Hi, Richard. What changes are you seeing in customer expectations for reality capture across AEC industry? And
so again, it sort of touched on the last one. It's just having it as another deliverable. They're wanting like that additional photorealism for the data, and then a lot of people are liking the Gaussian splats as a means of asset management as well. So, you know, especially, I don't know if it's like international, but especially in the UK, a lot of sites have like old drawings, and in the past it might have been like a CAD drawing or something that was produced to sort of show changes, but now we're seeing clients are wanting, you know, an actual like 3D Gaussian splatting visual as well. And then if there is like an area that needs a focus or is high risk, they can add tags and stuff to that Gaussian splatting model. So it's just making it a bit more visual and easier to understand, say, a site or an area.
Yeah, and from my side, I find that more and more customers' expectation for reality capture is to do some semantic segmentations, and especially for those facility management case. And the people also need to get the account or the total amount of the facilities, and also their positions, and some of the visualization case that they would also try to display the certain facility to mesh model or other kinds of data sets together. Yeah, so quite interesting. These days, people are quite flexible with all different kind of deliverables combined together, and to meet the different requirements and the communication needs.
Yeah, no, absolutely.
Yes, and another question from, I think from Select. In ProtoCam, what does the dual front lens do differently than a single lens in Lexo K2? Does the dual front camera record at the same time?
Do you want this one, or should I take it, Mindy?
Yeah. As for the designs, and actually we have different design concepts for the different series. PhotoCAN itself much more for the CDGS capture and the processing, and Lexo K2 is quite like a combination of the surveying grade scanner as well as output relatively good 3DGS result. And so to compare the results coming from two of the cameras, the scanners, for sure, I may say that PhotoCAN output the best 3DGS at this moment. A more dual front cameras, they record at the same time, but they still have different mission. And because of the another camera, the PhotoCAN can capture more details compared with Lexo K2 or any other scanners we provide. So actually different scanners also always have different emission. So, and I think that not only one hardware can meet all the requirements in all different kinds of the projects, I suppose. And I think this question also comes from Salah. Do customer request you to host the 3DGS scan file for them as share link, or you submit a raw file? And I think this one is for you.
Yeah, that's fine. I mean, it's not really our position, as we're sort of there as an XGRIDS partner, so we're not the one actually sending data to clients per se. But say if we're sort of helping someone onboard a scanner and then they get one for their own work, we would, you know, just send it as a share link, and then we'd send them the raw files as they're assessing the product as well. I think with customers that we work with, again, it would be the same principles. So when you're using the LCC, there's an option to publish it on an XGRIDS server, and then you can just send the web link that way and encrypt that with a password. So I know a lot of people do it that way, or a lot of people use existing platforms already. So I know Near is very popular for sharing data. So they might export it as a PLY file from the LCC, import it into Near, and then share the data that way. But it also largely depends on what platforms they're using. There might be a drone deploy user, and if that's the case,
Yeah.
they'd export it as a PLY and then import it in. So it really depends on what softwares you have in house. But yeah.
Yeah, so for me, the experience would be that it depends on the requirements of the certain clients. Some of them, they want to keep all the data sets hosted by their own private server, and they don't want the data sets to be public to everyone. So they will have their own private cloud to host all the data sets. So actually, as the service provider or some 3D graphers, we just we provide the solution for them to process the data sets locally, offline, totally offline, and keep the data privacy issue within their own server. It's quite safe things. But for the easy deliverables, and we can also make a quick host or the link that you can share it with your friends and data sets. So some of the customers, they only use that link for a short check, and so they may want the 3DGS scans being hosted by us. Yes, and I think we choose another one, and again from Freya, any scanning tips for church environment. There was one really nice heliguy did with Dalhon Church. Yes, I think you really have these kind of professionals to say that.
Thank you, Freya. Appreciate it. Yeah, I mean, usually when we're doing surveys, I try and avoid the need for not going back to site again. I want to do it there on site in the day. So as many images as possible with the drones. And then our experience has mainly just been from following the tutorials online and with what XGRIDS have. So 4 different takeoffs with the Matrice 4E, and then as you're sort of going up with the drone, tilting the gimbal towards the ground up until you reach the altitude that you're doing the mapping mission. And then with the scanner, again, just going around those sort of fusion points in areas where you have taken the drone off from, and spending plenty of time scanning, being conscious of different perspectives. So using the front camera and the side cameras as you're scanning, and trying to just get as much detail as possible. And then on the mapping route above the church, what we tend to do is we wouldn't just restrict it to an oblique mapping route. So the oblique mapping route is needed, but then on top of that, we might just do some of our own manual flights with the camera angle, with the camera point at like 45 degrees, and we'll do a series of crosshatch flight routes over the top. And then to get the general surrounding area, just some like orbit flights around it always help as well. So plenty of images, takes a while to process, but it will get you the best possible model you can.
Yes, and from my experience, like I think the 3DGS capture from the area part is a little bit different from the photogrammetry methods. And especially for the area ground map fusion functions, I think the most important part is from that taking off areas. Try to make more overlapping, and when we get back to that purely area capture, and to ensure that you got different height and angles, quite similar as the photogrammetry methods, and you always get better results with that 3DGS. And so I think this one is a very great one, and I suppose that many of the audiences who follow Helliguy's page would be curious about how you can capture such beautiful data sets. And I think this part being answered well, and let's introduce callers again back to the stage. We still have several questions to answer. I think both for two of you, or maybe some of us, and I think one from Peter Peter Butler. He just missed the section about AI. How do you make sure AI creates accurate layout so that the Gaussian splats work accurately with them? Sorry if it has already been answered. Do you want to add something, Carlos, or if you want to share any experience, Richard?
But I feel like I'm not sure if the question I think makes sense, but I feel like there's a different workflow that what I explained earlier is a little bit different because I'm not using the Gaussian splat to or I'm not using the AI to create the Gaussian splat initially, but I started to put together from the Gaussian splats visuals that they were not easy to be captured from ground level to inform the AI, at least for the case of the charts that I was showing. This remains here in London. But now that Alex was talking about some of the fusion ground control, so the fusion system that where you add more images to from the drone and everything, I find like incredible system. The fact that you can inform the construction of the Gaussian splat with image data sets from a drone, and I use it a lot because that's very useful to really capture things that you cannot capture from the ground level. When you need to create like a Gaussian splat, if you go with the scanner around a building, you don't see the roof or you don't see the top features of this geometry. So I find it like really good to inform the production of the Gaussian splat with those photos taken from a drone, which I think conventional photogrammetry require you to take like a very specific way, like very specific angles. But I realized what you can do is that with the HD enhancement option from you guys from XGRIDS is that you can just draw photos from many different angles from many different devices, and it still works very nicely, and it gives you a very nice reconstruction of areas that you cannot see. The later the Gaussian splat looks like beautiful and accurate from all possible angles, and the closer you get to the object, the better. So I learned a lot with you, Richard, and your tutorials and other things that you guys have in heliguy. Because I think most of the devices that I got there are from you. So I feel like I appreciate the service that you guys provide and all the work that you publish in your website. It's a wealth of information there.
No, we really enjoy working with you, and it's always good just seeing how far you've taken it with what you're doing for Zaha Hadid and what you're doing on your own work as well. So it's always good to see.
Yeah. So for me, I would like to see that more and more the projects combine the reality capture together with the AI solution. And I do agree with Carlos that actually the reality capture solution needs to avoid hallucination from AI if we want to keep that things be trusted. So every time people may ask that whether you adopt any AI or diffusion methods to increase the data quality for the CDGS processing result, I would say no. But AI can be applied into the resulting, the reality capture or the processed result, especially for those segmentation or some further applications, such as that. I also noticed several applications with that AI create some layouts of the Gaussian splats. And just because that the data sets, the original or the raw data set is accurate enough, which contains the geometry and physics information, so that the AI can create a relatively accurate or the aligned results together with the reality capture results. So that's the way that we try to tackle the issue in this moment, at this moment. And maybe in the future, the AI and the reality capture will have like different direction, but merge into one way, maybe. Yeah, I think that's the last question from the comment area. What challenges do customers face when introducing 3DGS into existing workflow? I think if you face several difficulties to promoting, or is that 3DGS already a very attractive solution?
I'd say from our side, probably the most common one we have is like not understanding how to capture with it. So I'd say sometimes, someone might think that they can get a portal cam out of the box, put it in the air for a minute, and then you'll get the best model you possibly can. And that's not reality. Like it's understanding the scanning routes and the workflow. So like it could be using the HD enhancement, but like closed loops within the scan. If there's a surface or an area you want in more detail, spending more time over that surface, and then that'll get you the good model. And then usually once they've got the model to the best of the ability, I'd say people are quite receptive to using that and getting it and using it within their current workflow. But from our side, the most difficult thing has probably been just understanding how to get the best data from the scanner.
So how about colors? Do you have any like the similar experience of persuading the customer to to adopting the new tech?
I think what my customers like in that sense for that specific question could be the Zaha Hadid, let's say, environment. I think because I work as an internal consultant with my team within this company, it's like our clients are directly the people who are actually creating the project. So we try to give them the best service and to them so they can come back to us, find us useful, and that's how we keep working and how we keep growing inside the company. And mainly the idea of adopting 3D came from the fact that we couldn't find a good, let's say, solution that can help us to integrate a realistic 3D visual of a space to sort of like an interactive virtual tour. Because everything that we looked at before, it was like either 360 images or this Matterport sort of visualization where you jump from one 360 image to another. It's a nice blending, but at the end, when you look out, the 3D model looks like not something that we like. So unfortunately for Zaha, they like for the realistic stuff to the point that they only rely on things that they look like either like what they want to transmit or a very accurate representation of what they're envisioning for their clients. So when we wanted to transmit to maybe our portfolio to another client and our environmental solution or the environmental features of these buildings, we found this could be very useful because we can scan the interior, the exterior, create a very, let's say, accurate to how the building looks like actually representation, and then share this internally with our project leaders. Help us a lot to really help them understand that this can be the future for you guys to transmit your portfolio to a client, or even if you're doing a construction process, if you want to transmit to your engineers or even the client how the space started to look like, you can just 3D scan that because a guy can travel with that in the backpack. You don't need like a massive suitcase of 20 kilos with a scanner, a tripod, and everything going there, surveyor style, because for us it's impossible. You have like very limited time, and when an architect travels to a site, they maybe spend no more than 2-3 hours and they have to go, and they have a massive agenda of things that they need to do. So we start allowing to go with this scanner to other project managers so they can 3D scan locations that they're interested to showcase, and when they have, for example, a mock-up, because normally they build one-to-one mock-ups of buildings. Now with this scanner, you can get a real feel. From normally what we used to do is look at pictures. Everybody look at pictures, and then you try to take as many pictures from many angles as you can. But we tell them that if you just go scan it, you can take any angle if you want later. You can just simply just look at your desk, and you don't need to. You can interrogate it from many different points of view. Obviously, the process of scanning we know is tricky. It's not always like you're gonna get the best results by just giving a quick circle around the location. You need to do it with details. So that means that we have been training, and we need to train people to really understand the workflow. But speaking of well, and I feel like people started to think that this could be a new way of representing things. That could be the future instead of just taking single pictures. Take 3D scans that are very fast and very nice to visualize these interiors and these exteriors. So yeah, a little bit that's my experience with that.
So one station experience and the convenience would be convince the customers. And on the other hand, from my side, I try to collaborate more with the ecosystem partner as well as to introduce the GS into the existing workflow. The first problem need to be tackled is to make that existing workflow can read 3DGS. So the read is the first step, and to work with the 3DGS within all the existing tools, such as for each industry people, Rhino, SketchUp, Revit, all these kind of software being used by all the architects, designers. They may know that you don't need to learn a totally new software or the pipeline to adopt these new things for their pipelines. You just use the original software or the previous all the software they adopt every day, so that they can deliver better results to the customers or all of the stakeholders through the lines. That would be for them. That would be better to receive that feedbacks, the active feedbacks for these new pipelines. And yes, that's the final question from the comment area. And I also have two questions to end this session. The first is that looking ahead 3 or 5 years, or immersive spatial environments become a standard layer alongside BIM for architecture and construction projects. Do you think that would be the truth for the next 3 or 5 years?
I think it should be.
Yeah, definitely.
Yeah. I mean, so Richard, do you want to go first? Because I was talking earlier.
No, it's okay. You can go. If you were going to say something, it's fine.
I think like from our perspective, what I see is like we rely a lot of. I mean, Zaha Hadid especially works with cutting edge technology. So every time that looks new and flashy and impressive, we just try to bring it to the office, and we have incredibly talented people with like amazing skills that they keep renovating the skills with all these technologies. So when we see something new that can be interesting, we just look at it and work on it like we're scientists. So I feel like my team and I, for example, work on doing this scannings now, but we have a lot of people working with a lot of different tools and different workflows, and they use a lot of BIM. They use a lot of different 3D modeling tools like Maya, Rhino. BIM became quite useful in the later stages of the project to start creating a model that can be built in the future, or can be gathered by an engineer and develop it to construction drawing level. But I think like what we realized that it's very useful to see 3Ds or images of the process, and then we like to see the evolution, because we learned a lot from looking at how things look like. We learn a lot from the people that work for us, like manufacturing companies that have impressively accurate or highly specialized equipment to deliver complex shapes. So for us, we trust images at the moment. We trust by sending people to a location. This person take few photos for us, and internally we review the quality. So it's kind of like a quality assessment that requires a person going on site taking photographs. And between the opinion of the people in our office and the opinion of the people on site, that's how we make agreements with the clients. So we tell them, guys, maybe this is not what we're expecting. Maybe you can improve it by doing this or that. Or from there, we can know, it's like, wow, this exceeded our expectations. We'll go ahead, green light. But what we realized that we could have a 3D model that looks photorealistic, this process would be way more informed. And that helped us a lot, because when we see this sort of realistic visuals, we can even go and see the joint. We can see the detailing. We can see the glossiness of a material. So I think we see this improving a lot, to the point where we can use it for informing our own design process, and even from learning of our own, let's say, manufacturing process in different stages. So yeah, I find it really useful. I feel in the future Bali will be more extended, and if they see companies like us doing it, maybe other companies will try to follow, because they will be curious to see how this can improve their workflow. So I basically encourage everybody to rent something from you guys, from heliguy, because we did that. We rented a scanner, we wanted to test it, and then that's how we convinced, by looking at the results, we convinced the people in our office by sharing results with them. And that process helped a lot. Yeah.
No, yeah.
How about Richard?
I completely agree with Carlos, and yeah, no, that's exactly why I have the rental fleet, just so people can sort of test it and see it before they go into using it and getting a feel for the data. And yeah, it's exactly the same. Just following on from my presentation as well, is it's only going to grow, and as more viewers support it, and more sort of software companies look to support the file types produced, and like the LCC2 files open source, it's just going to continue to grow. And as in the UK, we have a lot of sites where there are like drawings that are outdated, so you could either just send over the same drawing again but newer and up to date, or you could have like the visual from the splat as well. And I think for that reason, it's only going to grow in popularity.
Yeah, and for me, I also noticed that more and more the immersive experience has been added to this field. For example, to use VR or XR to represent the data sets, and people can get a more immersive and interactive way to get to know the data sets and all different details from different perspectives. And so I think for sure that would be the future chance. And thanks for this answer. The last question should be that what role could AI play once high quality spatial data becomes widely available? Yeah, because these days we notice that AI has already got a lot of data trained with the images and texts, but actually the 3D and the real space world is quite like a blank for that for the AI things. So maybe that AI can have a next level evolution when the high quality spatial data sets available everywhere. So what do you think?
Well, I think it could be quite useful now if AI can be trained with these data sets. I'm not the
Mm-hmm.
developer of the software or the tool itself, but to my understanding, I feel that could be it would be a game changer because in the future that could really improve, especially the production of 3D models out of photos. I feel like I use that word for a little bit, and when you see how 3D models are obtained from photos, I feel there's still like a gap that hasn't been covered. You don't get like 100% accuracy in this production, but I see that AI has changed a lot. In our office, we use AI a lot for creating new concepts. Probably you've seen the type of Zaha Hadid buildings and the geometry that this company is famous for. Everything looks quite organic, quite avant-garde. There's normally no straight lines in our buildings very often. So now what we realize that the AI became quite useful for starting to envision some of these complex geometries. But obviously, you think about it, the proposal that AI is doing for you is coming from an AI engine. You just kind of like trying to describe in the creative process, you try to describe what you want or make a sketch. And then now I see that people who start to blend their own kind of sketch with their own intention to apply on top of it, let's say materials or textures are becoming more popular because a few like months ago or a year ago, everybody was crazy with prompt engineering. They were like doing prompts, but the result it was very wild. It was like whatever the AI wanted to give you. But we see there was a shift, and I feel that's also because AI started to be trained with more images or more accurate workflows, so it can predict better results or results of what you really want, which are connected to your visualization. So we do a lot of basic 3D models, and from there we create the rendering parts with AI, which is faster and give you photorealistic results. So I see that in the future, maybe this feedback loop will come directly not from images, but also from Gaussian splats scanning. But of course, now it's like this gray area, it's like how are you sharing that? What's the terms and conditions of sharing a 3D data set with a company? Can we host it safely so nobody take it or no engine can take it? I feel that would be a lot of debate about, the implications of how these 3D data sets travel around the ether of the internet to feed these companies who are doing or let's say profiting from that, because also that can be another topic. But again, I would just leave it up because that's not my hand to answer, but I feel it will be an interesting debate in the future.
Mm-hmm. How
Yeah,
about
no,
Richard?
absolutely. I think, I mean, it's obviously going to have a huge place. Like AI has a place in every industry and continue to grow. I mean, again, similar to Carlos, I'm not the software developer, but we'll see how it goes. But I think from like again an asset inspection side in that industry, can AI be used on a Gaussian splat model to detect faults and taking another person out of the loop, but making the whole process easier, more seamless. The possibilities are endless. Like it could generate PDF reports on a project from a splat. So it's exciting to see where it goes, but we'll definitely have a part as time goes on.
Yeah, and to add some information that as for XGRIDS, actually we not only provide that reality capture solution, we also try to provide more like spatial intelligent things, because these days we found that AI got some still have some bottleneck of understand the real world, and if we got enough available high quality spatial data sets, actually the AI or some embodied AI. So can reach some term that we call like physical AI. So that if they in the past that they cannot enter into the real world by some mission tasks be finished with some text and the pictures, but these days they can understand the whole environments, the 3D environments in a more smart ways. And maybe for the architecture, that can be a more smart architecture system, and the system itself can realize where is the risks, or maybe the embodied AI can also localize or position the problems happen in specific area. So that's why we also try to advocate that reality capture data can be adopted by the spatial AI and the physical AI things. But I still think that those spatial data sets are not only available and visualized by people, it can be visualized by all the computers, robots, and AI models, so that we can interact with that data sets with the natural language. For example, in a property or in a building, we can use the natural language to know that how large is the area of the second floor and how many rooms and how many rooms in this building, how far from this building to the hospital or the schools. So that's kind of information can also help the people to get a better decision making, or even live better with the architecture itself. so that's also the thing that I can envision, even though I'm not developers. But I do see several projects adopt those kind of spatial data sets together with the large language model, which I think is a very intuitive way for people to interact with the spatial data. Yeah, so I think also very promising, not only with those areas.
I think we're losing
Only
Mindy.
I think we're losing you a bit, Mindy.
I was thinking it was on my end, but I see your face,
Yeah.
so you were like
Yeah.
moving normal.
Yeah, we will keep
So let's see if she can come on.
Is she back now?
Yeah, so let's say goodbye to everyone. I got another connection problem here.
No worries.
It's all right.
It's
It's been
okay.
very nice to
Yeah.
thank you for the invitation.
Thank God it's the end, but it will not be the end of the series. See you in the next webinar.
Super.
Thank you so much,
for your
Mindy.
time.
Thank you, Richard.
Thank you. Cheers.
Bye bye. Thank you very
Bye,
much.
Mindy. Thank you.
Bye.
Bye.